This is an expressive practice sample. You have been asked to render a message for a deaf middle school science student. The class is learning the scientific method. You will have a 1-minute warm-up followed by a 1-minute break. After the break, you will begin interpreting or transliterating. The warm-up will begin momentarily. All right. Our next unit is on the scientific method. The scientific method is the process that most scientists follow in order to test an idea. The scientific method was developed by a lot of people, but it's largely credited to Galileo Galilei. Granted, Galileo is influenced by the work of Sir Francis Bacon, who can be considered the father of the modern scientific method that we use today. But most of the Western world attributes the credit of the scientific method to Galileo Galilei. You can see it credited to him, Sir Francis Bacon, Sir Isaac Newton, or even people way before them, like the ancient Greeks. But for our uses, we're going to say Galileo Galilei. So the scientific method has 7 steps. It could be 5, it could be 10, depending on who you ask, but we're going to go with 7. So, like wanting to know anything, the first step that you have to do is ask a question. This is the same for the scientific method. The first step is asking a question. It can be any kind of question. Who did this? What happens when you do this? When did this happen? How does this work? Why does this work? Where does this happen? Which of these 2 options is better? Any kind of question like that is where you start your scientific method. So, for the sake of our experiment, we're going to be asking which falls faster, a tennis ball or a basketball. The next step in the scientific method is doing background research. This background research will help inform your process. Basically, this will help you look at what other people have done, other people who tried to answer this question. What happened when they tried to answer this question? What flaws were there when they tried to answer it? What did they do? Gathering this information will help you decide what you want to do similarly and what you want to do differently. The next step is going to be making a hypothesis. So this is where you come up with your idea of what you think the answer will be to your question. So if our question is, which will fall faster, a tennis ball or a basketball? You may say, I think if I were to drop a basketball and a tennis ball, then the basketball would fall faster. So the structure of a typical hypothesis is an if-then statement. If I do blank, then blank will happen. If mothers use breast milk, then their child will be healthier than a child who is given formula. If I give $100 to 5 16-year-olds, then they will spend it more wisely than a group of 5 25-year-olds. You're trying to give what you think the answer will be to your question in an if-then statement. If blank, then blank. If this happens, then this will happen. The next step in the scientific method is testing your hypothesis. So our hypothesis is, if I drop a tennis ball and a basketball, then the basketball will hit the ground first. So then you test it. In order to test your hypothesis, you have to get together everything you need to talk about how you're going to do it. Then you do it and log the information that you gather. So we're going to say you get 3 kinds of basketballs and 3 kinds of tennis balls. And you drop every kind of combination of basketball and tennis ball, and you record each time which landed first, the basketball or the tennis ball. And you're going to film the ground where they land so you can see which one landed first. Okay? So you do that. You test every combination of basketball and tennis ball. Then you have finished testing your hypothesis by doing the experiment. The next step in the scientific method is going to be analyzing your data and drawing a conclusion. This is where you look at all the information that you gathered when you tested your hypothesis. You're going to analyze it, and then you're going to say, okay, what does this data tell me? What is this data saying about the hypothesis that I tested? What is this data saying about my experiment? If someone else were to look at my data, what would their conclusion be? And then you write that conclusion. So if we were to do it and we saw that the basketball landed first every time, we would analyze our data and say, okay, the basketball landed first every single time. Our conclusion will be that if you drop a tennis ball and a basketball at the same time, then the basketball will hit the ground first. Next is being able to talk about your results. That is where you give like one final gathering of all the information as well as your conclusion. So in our example, we're going to be writing an essay discussing your whole process.